Thank you. Good morning, everyone. It's great to be back with you all. So we're going to take a journey from the early days of Cesium, where we started for visualization and analysis of aerospace, to today, where we join Bentley to advance infrastructure by combining iTwin and Cesium to build the open platform for the built and natural environment. I have a lot of stories. I have a lot of videos. Before we get started, I'm curious, how many folks knew of Cesium before the acquisition? Show of hands. Oh, a good number. Okay, very nice. And what about how many folks have either used Cesium or maybe one of your colleagues have used Cesium? Okay, wow. Maybe about, for the folks that are joining us through the live stream, about a third of the audience has used Cesium or their colleagues have. Fantastic. Okay, so as we reflect through this journey, there are three themes that will keep coming up over and over again. The first is that of community. So as Julian and I spoke about this morning, it wasn't like I had some grand vision 13 years ago and I put the pen to paper and wrote this 100-page document on how things were going to play out. It wasn't anything like that at all. We did open source software, we engaged with the community, we listened to them, and they helped us see how our vision could become bigger, bigger, bigger. So point one, community. The second theme is ecosystem, and we've already heard a lot about that this morning. As a society, we're facing really big challenges, like climate change, or the skilled labor shortage we heard about from both Joe and Nicholas. No one organization is going to solve all of our problems. Instead, we want to focus on where we can create the most value, and then we want to interoperate with solutions from other organizations to empower our users and to empower developers to build with best-in-class products. And then finally, openness. I just can't tell you how happy I was to hear so much about openness from everyone this morning. And we've used open source software to build trust so that the community will help guide us. That's one form of openness. The other, we've heard a lot about open standards. That is the conduit that allows interoperability to connect the ecosystem. And then, of course, the open APIs that allow software developers to connect everything. So we'll talk a lot about these themes as we go through this journey. All right, so let's go back in time. I finished undergrad about 20 years ago. I'm from Philadelphia. I wanted to stay in Philadelphia. And we know that Bentley was founded and our headquarters is in Exton. So when I was finishing undergrad, I literally just looked at the companies recruiting at Penn State. They're in alphabetical order, and I wanted to do graphics. And there's a company that began with A, so before B, A, analytical graphics. And I joined AGI and started doing software development for aerospace visualization. Think a spinning globe, satellites orbiting that globe. So in 2011, it was the dawn of 3D on the web, right? GPUs were becoming pretty widely adopted out there. JavaScript was becoming fast enough as a programming language, and a consortium called Chronos had the WebGL standard that allowed you to do hardware-accelerated 3D on the web. So as an aerospace company, we took a look at this and said, hey, can we take our 3D visualization and then make it available on the web, make it available to software developers? And it turned out that the answer was absolutely yes. Okay, and I'll show you an example of that now. So what we're looking at here, this is a partner of Cesium called ComSpock. They do SSA, Space Situational Awareness. They literally track objects in flight in space, and they try to predict where they'll go, and if there's potentially collisions, which then could create debris, and then create even more traffic out there. That app is called Spacebook. You could go to spacebook.com. It runs in a web browser. So we did this. We met the technical challenge. The next idea I had was, well, I love open source software. We use a lot of open source software. Wouldn't it be so cool if we could put this out there for the developer community and see what they would do with it? Now, keep in mind, AGI, commercial software companies selling licenses, and wanted to know, okay, well, Patrick, what's the business case if we're going to do this open source software? So, I just took out some books. I'm like, let me try to learn about that. So I think it will open up new markets, I told them. They very reasonably asked me, and they said, well, what new markets? And I shrugged my shoulders, right? It's amazing if we could go back in time and talk to the me of 2011. But over time, they said, okay, let's try it. Let's make it open source and let's see what happens. And it became very interesting. So keep in mind, we've made this for aerospace. But in order to do aerospace, you actually have to be very good at visualizing the ground, because we care a lot about the communications from a sensor or a ground station out to a satellite that might be coming overhead. And things like terrain or 3D buildings may block that. So we made a very capable global terrain engine that could stream in that content as well as overlay satellite imagery. Now, with the power of open source, we then learned, well, we're not just in aerospace. It turns out that we're also in geospatial. And one of the things that really opened up our mind was Red Bull. They picked up Cesium to do a digital twin of the X-Alps. So this is a paragliding and hiking race through the Alps. Each of the athletes has a sensor on them that's sharing their location. And in real time during the race, you can go to the website and see this digital twin and see where all the athletes are. It really opened up our eyes. And as we'll start to talk more about ecosystem and interoperability, you'll see the base maps overlaid there were provided by Esri. Okay, so now we can do this high fidelity globe on the web. We're empowering software developers. But we also want to be able to put individual 3D models there. So think maybe a satellite, and the satellite has solar panels, and we want to be able to see those solar panels pointing towards the sun to power that. We wanted to also make sure that there are lots of options to be able to create this 3D content, to be able to use tools like the open source Blender or Max and Maya, so that artists could create this and bring it into that virtual globe. Well, there was one format out there called Collada. It was an XML-based format. It didn't feel like it was appropriate for the web. Maybe it wouldn't be efficient enough to be able to download and render on the web. So I did what many reasonable engineers would do, and I started making my own format that I thought was going to be really efficient, perfect for the web. I'm very happy to say that I also noticed that Kronos, the same group that created WebGL, the open standard for 3D on the web, was working on an open standard for 3D models that could be very efficient on the web, and it called GLTF, the GL transmission format. It turned out that the design was almost identical to what I was designing. So when we saw that, we said, whoa, well, let's start using this, let's start contributing to this, let's start talking to these folks. And it was very early days, right? The ecosystem at the time was really two open source engines and then a converter from Collada and OBJ. But over the years, as we worked with the community to create this 3D model format, it got very widely adopted to what we see here today. And one of the key milestones there was Microsoft was doing 3D for everyone, and they were looking for a 3D model format, and they came to Kronos and GLTF. They wanted a phone call, and I remember I was on vacation. I was at the beach, and I'm like, oh, this is going to be important, though. We need to take this call. And when they adopted it, it really helped create this inflection point. And now we see it widely adopted among authoring tools, converters, desktop engines, web engines, a very robust and interoperable ecosystem. No one organization could have created something like this. Okay, so here we are. We have this 3D globe engine on the web. We can put 3D models into it. But the data acquisition trends really started to show us that we needed a lot more than terrain and satellite imagery. There were LiDAR collecting these massive point clouds. There was open data from a lot of city governments providing 3D buildings. There were drones taking photos, and then the photogrammetry algorithms were producing these massive models. And people kept coming to us saying, hey, we want to put this in context on this Cesium globe. And all these things, they sound very different, right? But it turns out that they have a lot in common if you want to try to stream and view them in the Cesium globe. And you can use a similar technique for all of them called HLOD, hierarchical level of detail. So we built something that we called 3D tiles, which was an open specification to define how to do this hierarchical level of detail, how to take these massive photogrammetry models, these massive point clouds, and stream them in that geospatial context. We put it out there as open on GitHub. We spoke about it on our blog. And then a group came to us called OGC, the Open Geospatial Consortium. And Scott Simmons there said, hey, Patrick, we think you're onto something there, and we'd like you to bring it to the open standards community to encourage adoption and to build awareness. And we have this community standard process. And we said, well, wow, that sounds like a great idea. And these here, by the way, these are original images that we showed at the first time that we presented this to OGC. The top one's from Virtual City Systems. The bottom one is from Vricon, now part of Maxar. So when we did this, we formed a submission team that included Cesium, and included the NGA, National Geospatial Intelligence Agency, and included Bentley Systems. This is back in 2017. So let's talk about how Cesium and Bentley met. It's quite an interesting story, because you got to keep in mind, we're 15 minutes apart. We're essentially neighbors, right? Well, the context capture team, now known as iTwin Capture at Bentley, based in France, was checking out Cesium because it was open source. It was easy to consider, and they were going through our code examples. And one of them had satellite imagery zoomed in to Exton, Pennsylvania, right? It's like, that's pretty interesting. And then folks got talking and said, hey, the Bentley folks were like, hey, we should talk to the Cesium folks. So that conversation started, and again, guided by the community here, Bentley opened up my eyes and opened up Cesium's eyes and said, hey, you can do a lot more than geospatial. You can do infrastructure. And these are images from a 2017 blog that Cesium and Bentley did together. So the one on the bottom is Penn State campus. In the distance, there's global terrain and imagery, but the campus itself is photogrammetry or reality models that came from iTwin Capture. And then there's a proposed chemistry building that came from MicroStation. So you're seeing geospatial context, you're seeing multiple data sources, engineering and geospatial coming together. So we're quite ahead of our time then, but seeing also Bentley's commitment to helping advance 3D tiles and advance open source Cesium.js back then really shows the ethos of the organization for what we're going to do together now. Okay. So another thing that really opened up my eyes was meeting Komatsu. So drones became very popular for taking photos and doing reality models. And Cesium became very widely used for that because it was open source, easy to get started with. So there's a company, Komatsu. They're number one in Japan. They're number two global for heavy machinery. Think bulldozers, excavators, dump trucks. And they've seen the challenges that we see. They just want increased efficiency, increased safety. They want to be more environmentally friendly. And they have a whole smart construction initiative to do digital transformation of the earthworks construction site. Well, drones were one of the techniques that they would use for surveying, in addition to traditional rover surveys, and also getting edge-built data off of the machines themselves. So as they were looking at different drone solutions, they saw Cesium over and over and over again. And then they came to us and they told us about their smart construction vision. And we looked at it and we said, wow, like this is perfect for Cesium. And we would love to be part of this. So for a number of years and into the future, we've been working with Komatsu to do this digital transformation. And now to take it to the next level, Komatsu's formed a joint venture that's called EarthBrain, that's also with NTT, NRI, and Sony. Okay, so I spoke a lot about doing the 3D on the web, right? But we do a lot more than the web today. You've seen a couple great examples of using Unreal Engine. I want to tell you how we got there. So 3D tiles, the open standard, it got adopted by the U.S. Army One World Terrain program. This is for their virtual training and simulation. And they had, quote, 57 different terrain formats, and they wanted one well-formed format. So Cesium worked with Vricon, now part of Maxar, and 3D tiles was selected as that well-formed format. And it's a great example of government helping advance open standards. So once Cesium got adopted, well, lots of folks wanted to start implementing 3D tiles. And Epic Games was one of them. And Epic came to us and said, hey, we want 3D tiles in Unreal Engine. like totally, we use Unreal Engine to make Fortnite, but Unreal Engine is also a real-time 3D engine for all sorts of modeling and simulation. And you would think as engineers we might be like, well, we do our own rendering, we do it on the web, we don't want to do anything anywhere else. But that was not our mentality at all. Our mentality was abundance. We want to integrate everywhere. We want to build bridges, and we ultimately did build this open source Cesium plugin for Unreal Engine. And wow, I have to say, when we released this, like we made 10 years progress overnight. We built this bridge between real-time 3D engines and geospatial, and it was just so unlocking. Really impressed with it. The other part of this story was that Epic actually supported us with a mega grant to fund the software development. And that inspired us because more recently, we released our own ecosystem grant program to, again, fund the community to do open source projects to expand the ecosystem. And we supported 3D tiles in QGIS, in Godot, and in 3JS, among many others. Okay, so let's talk about the Olympics. So, I'm not embarrassed to say that in 4th grade, I was cut from the basketball team. And it gets worse. In 5th grade, I was kicked off the football team for bad grades. It was spelling. I didn't even have to go to summer school because they didn't have summer school for spelling. And then in high school, I was actually like an okay wrestler, but like I never would have made it to the Olympics. But Cesium software did make it to the Summer Games in Paris. So a few things went into that. One is we heard a lot about Google photorealistic 3D tiles today, and Google's made that available to the ecosystem. So NBC Sports brought together Google photorealistic tiles, Unreal Engine, and the open source Cesium plugin to make these great experiences that you might have seen on TV, where you fly through Paris and then it zooms in to the arena where an event is happening. Did anyone see this on TV? Nice. Okay, again, that's maybe 25%. Okay, great. The other thing I really like about this is I had such a hard time trying to explain to my friends and family, like, what do I do for work? Like, what is geospatial? Now I just point them to this. Okay, so let's talk again about expanding the ecosystem. So when we built Cesium for Unreal Engine, we designed it such that all of the core data structures and algorithms and all of the heavy engineering lifting to do that 3D tile streaming, so that as you're flying through that world, it's incrementally loading the right data. We put that in a separate open source library called Cesium Native. And what that did is it allowed us to now quickly go do additional integrations. We did an integration with Unity, and then we also did one with NVIDIA Omniverse. I think we probably all know of NVIDIA for their GPUs. They also have a software platform called Omniverse for industrial digitization, and it has a lot of connectors based on USD, as well as stunning visuals like you see here. So this is the RTX GPU accelerated path tracer. It simulates sending millions of rays through the scene to get these really photorealistic images. Really fantastic. Okay, so let's talk about other industry expanding things that we've done. So for many years, Cesium and Esri have collaborated. And we recently put together a blog to show, like, wow, how much has actually happened. And when you look at this, so Esri, ArcGIS Pro, ArcGIS Earth, as well as Scene Viewer can all bring in the OGC 3D tiles community standard. Really fantastic. Cesium JS can bring in ArcGIS terrain, and then there are like 20 tutorials from Esri on how to bring in Esri location services in the Cesium JS, such as routing and feature styling. And then in addition, Cesium JS can bring in the I3S community standard from Esri. So again, giving developers lots of options to combine different solutions. Okay. The other thing I wanted to talk about was how we've been seeing this great opportunity to work with architecture, engineering, construction models, and infrastructure models. So we recently started a technology preview that takes built environment content from IFC or from Autodesk Revit It brings it through and generates an efficient 3D tile set, both the geometry, but also all of the metadata associated with it, so it can be queried and filtered. Here we're showing it in Unreal Engine. It's going to be great to bring this together with iTwin and see where it can go. We're looking for your feedback on how we go about that. Okay, so I want to start to wrap up with a few examples. One is we saw Joe on stage earlier from Pinoli. Actually, a pretty interesting story here. So the week before Cesium joined Bentley, you could imagine, like, we were super busy, right? And I myself was very busy. But Cesium also does a lot of community events where we bring our team together and we bring the local universities, local nonprofits, any local users. And we had a Phillies game. And I'm like, man, I really want to go to this game. So anyway, I did go to the game. And then, Joe, I met one of your colleagues there, Joe Spadea, who co-founded the Pinoli FX. And I have to say, he was so enthusiastic about what they were doing with Cesium, just really grabbing technology and bringing the visuals for digital twins, especially bridges, to this whole other level. And here's something we just put out on the blog here that's shown the Delaware Memorial Bridge, and then the upcoming cylinder protection program they call Dolphins, just to protect the bridge from wayward ships. So it's Unreal Engine, it's Cesium, it's Google Photorealistic 3D tiles, very immersive, very compelling, great to share with stakeholders. Okay, so no Cesium talk would be complete without NORAD Track Santa. All right, how many folks track Santa on Christmas Eve? I saw these. Okay, nice, very nice. How many people are going to track Santa this Christmas Eve? All right, good. So we've been doing this since 2012. So NORAD has a very sophisticated program. They have jets, they have Santa cams, they have satellites in geosynchronous orbit, and they have radar. And they find Santa's exact location, any moment, Christmas Eve. Millions of us, kids of all ages, running devices of all types, go to the NORAD Track Santa website. We see where's Santa and how many presents has he delivered. Santa's delivered as a open source GLTF model or open standard GLTF model. Then we have the globe from Cesium. So it's a lot of fun. It's a great mission. And it also shows the robustness of the platform at scale. So I have a mind-expanding idea for everyone. So we recently released Cesium Moon Terrain. I think it's coming up in a moment here. Next slide. Boom. Here we go. This is a 3D tile set that curates open data from NASA. So it's a digital twin of the moon. Okay? It ranges from 1 to 100 meters for the imagery, then 5 to 60 meters for the terrain. And it allows you to build these simulations of the moon. You could do it in Unreal Engine, you could do it in Cesium.js, or anything that supports 3D tiles. Where this becomes interesting for infrastructure is there's a lot of interest now in building infrastructure on the moon. And folks think it's probably pretty unrealistic that we're going to send the building materials there from Earth. And instead, we're going to break down parts of the lunar surface and 3D print it and then construct it on the moon. Something like this, no one organization is going to do this. We need an ecosystem. We need the collaboration of the community. Okay, folks. So look, it's been a lot of fun chatting with everyone this morning. I just want to reiterate the way that we're going to move iTwin and Cesium forward together is this engagement with the community, looking at the success for the collective ecosystem, and then being very open source, open standards, and open APIs. And we need everyone's help to drive the direction. I look forward to chatting with everyone. Thank you.